morning, 7th grade. We're going to start off this week by beginning our 22nd module, and this is on the volume of cylinders. Module 22 is, all about volume. So in module 22.1, lesson 22.1, we're doing volume of cylinders. And then in 22.2, we'll be doing cones. And then finally, we'll wrap it up in 22.3 with spheres. So you're going to learn 3 different formulas for finding the volume. Again, just like our previous unit, you're not going to need to know these formulas for next year in algebra. However, when you get into 9th grade and you will all most likely be in geometry, this will all be used. So to start off, we aren't able to actually do the explore activity, but I liked, we would have done this in class together because I have these unit cubes, but I wanted to show you the image because it's very helpful for understanding the volume formula of a cylinder. So as your opening task, you were asked to name some things that you knew were in the shape of a cylinder, and one of the most common one that students provide as an answer is a can. Whether it's a soda can or a can of soup or a can of tomato sauce, a can. So basically, to give you the formal definition, a cylinder is a 3-dimensional figure that has 2 congruent circular bases. So there's a top base that's in the shape of a circle, and a bottom base that's the same exact size, and they're lying in parallel planes. And they're separated by this height here, okay? The volume of any 3-dimensional figure is the number of cubic units that we need to fill the space that's taken up by that solid figure. So what we would have been able to do in class, but we can't, so I wanted to at least include the picture, is what we would do is we would see how many unit cubes it would take to fill the bottom, and that would represent the base, right? And then in order to fill that up, we would need as many layers as the height. So what we do is we would have stacked up the cubes to see how many layers of that bottom base we would need. So if you think about it, to figure out how many unit cubes you would need to fill up, you would need to know the area of the bottom there, right? However many cubes it takes to fill that bottom space would be the area of that base. And in this case, our base is a circle. And then we would need layers of that area. And that represents the height of the cylinder. So if you need to find the volume, what you're going to do is you're going to take the area of the base and you multiply it by the height, because that tells you how many layers of that base you can stack inside the soup. And I'm kind of bummed that we can't do this in class because it's really a good hands-on way to understand this formula. So to actually introduce the formula to you, it's exactly what we just said. We take the area of the base and we multiply it by the height. So if you remember back in, was it 6th grade? To find the volume of a prism, what we had to do was take the area of the base and multiply it by the height. I don't know if you guys remember, the big B, was separate than a base. It represented the area of the base, right? So to find the volume of a cylinder, it's just like a prism. So you're finding the area of the base and multiplying it by the height. So in our case, the base of a cylinder is a circle. So the area of a circle is pi r squared. And hopefully you remember that. Cherry pie is delicious. Apple pies are too. I'm sure you remember that. And then you multiply that by the height. So to find the volume of a cylinder, you use this formula, pi r squared h. The pi r squared represents the area of the base, and the h is the height. Okay? It's very simple. So anytime you need to find the volume, you look for your radius, and we always remember that the radius is half of the diameter. So if you're given the whole length across, you have to remember that's the diameter, and to get the radius, we'll divide that by 2. And you square your radius and multiply it by the height. Okay? and I'll tell you what we're going to do with pi afterwards. So let's get right into an example so that this makes sense. We're going to take a look at these two cylinders, and we're going to find their volumes. And in this section of geometry, we are told to use 3.14 for pi. Last year, when we did do volume, I think it was with you guys, I told you that you could leave your answer in terms of pi. Now that you're allowed to use your calculators, I'm going to ask that you do follow the directions and use 3.14 when you're asked to. If you're not told, you can leave your answer in terms of pi, and I will remind you what that means in a second. So if you don't have your calculators yet, make sure you go grab them real quick because we're going to use that. If you need to pause and grab it, now would be the time. Okay, so to find the volume of a cylinder, remember that sometimes figures look different when they're facing a different direction. So this is a cylinder, and even though this is down on its side like this, it's still a cylinder. It still has the two circular congruent bases separated by this height parallel from each other. Okay, so in order to find the volume of a cylinder, the first thing I'm going to do is I'm going to write the formula. So it's the area of the base times the height. The base is a circle, so that's pi r squared times h. We don't write the times in between there, you just write it all together, pi r squared h. Now I do what I always do, I label everything. So r is my radius, so I take a look and make sure I have the radius instead of the diameter. So I do have the radius, so I can just write 3. And my height is here, and that's 10. So in order to find this volume, I'm going to plug everything in to this formula. So they're asking us to use 3.14 for pi. So what I'm going to do is I'm going to put everything in parentheses like this. 3.14 for pi. And then r squared is 3 squared. I'm putting that in separate parentheses. And then h is 10. So what I'm doing this because I want you guys to enter this into your calculators exactly as you see it. Your calculator will do all the work for you if you use the parentheses. So let me show you what I mean. Okay. I'm going to use the parentheses which are here. Parentheses 3.14. Close your parentheses. You actually don't even have to push the multiplication sign. Just the parentheses again, just like you see in what you wrote out. 3, and if you have a graphing calculator, your squared buttons here. And then you close your parentheses again. Open a new parentheses to multiply by 10. And close them again. So notice I didn't use any multiplication symbols or anything. All you have to do is push enter, and it will calculate your answer for you. And it's 282.6. And one thing you have to always remember with volume and any kind of actual calculation in geometry is that you must include your units. So this is inches. And remember, we're multiplying inches times inches times inches. So volume is always cubed. So my answer is 282.6 inches cubed. Okay, so let's do another one. This time, we're going to look at the cylinder that is on its side. So first thing I do is I write my formula. The volume is equal to the area of the base, which is pi r squared times the height. So pi r squared h. R equals h equals. So now let's take a look at my diagram. I have 6.4 centimeters. Make sure you don't jump to conclusions and write that down. What you should notice here is that this is a full line stretching from the top, from one end of the circle all the way to the other circle. That means that this is a diameter. It's not your radius. So you have to be careful. In order to get the radius, you're going to divide this by 2, and that's going to give you 3.2 centimeters. Okay, so your radius is 3.2, not 6.4. Be very, very careful. And the height is, of course, it's what separates the two circles. Please try not to think to yourself that because this is top to bottom, that's the height. The height is what separates the two circles. So even if it's on its side, that's still the height. So that's 13. Okay? And now we're going to plug everything in. So V equals, in parentheses, 3.14 for pi. Close your parentheses. Now, r squared, I'm going to open up parentheses again. And I'm going to do 3.2 squared. Sorry. And then in the final parentheses, I'm putting 13, close parentheses. And now I'm going to put that all in my calculator, just like I did before. I'll show you again just in case. Parentheses, 3.14, close your parentheses, open your parentheses, 3.2 squared, close parentheses, open, 13, close. It should look like that, and then all you do is push enter. And we get 417.9968. I'm going to write the whole thing out first, and then I will round it. So it's 417.9968, and they asked us to round to the nearest tenth. So that's here. If I'm rounding to the nearest tenth, that's going to change into a 10. So I'm going to actually end up having a whole number here, which would be 418. Look for your units, centimeters cubed. And that's my answer. So it's very easy. It's just a matter of getting used to using 3.14 and, of course, having your calculator ready to go. If you don't have your calculator for this, you're going to be spending a lot more time on these problems. So make sure you use your calculators. If you're going to try to use your phones for the calculator, you may end up with some mistakes. The iPhones in particular have been known to have errors using the calculator. So I would be careful with that. If you have an actual calculator, whether it's scientific or graphic, please try to use that. It's better just for you to practice with, and overall it just is a better result. So I know most of you have one already. Some of you have a graphing calculator already, so it's good to just get used to using it anyway, because it'll be something we use daily next year. Okay, so moving on, I'm going to have you guys try these two on your own, just like we've been doing. So give this video a pause and try these two on your own, and then unpause it. One thing I'm going to say is your problems should look just like this when you finish solving them. That is the work that I want to see, and if I don't see it on the test, you're going to lose points. So make sure you show everything here on the side. Make sure you're careful about the radius and the diameter, and then we'll talk about the next section. Okay, so here are the solutions, and your work should look exactly like mine. I don't want to see anything off to the side, multiplying without the formula written. I want to see R and H written out. I want to see everything. So formula RH, R here is 5 because the diameter is 10. Make sure you look carefully at that and don't rush and write down the 10 for the radius, because the diameter is 10, which means the radius is half of that, which is 5. Plugging this directly into my calculator, I get 471 inches cubed. And for 5, again, I'm taking a look carefully. Remember, if your cylinder is on the side, doesn't change where the height is. The height is what separates the two circles. So the height is 12 and the radius is 4. Plugging that in, I get 602.88. We're told to round to the nearest tenth, so that turns into a 9. So 602.9 feet squared. Okay, to finish up, we're going to, that's the next lesson. To finish up, we're going to look at an example where we're finding the volume of a cylinder that's in a real world context, which you will see on your homework. So the example we have here is finding the volume of a bass drum by using the formula for the volume of a cylinder. So one of the bass drums that's used in a marching band has a diameter of 18 inches and a depth of 14 inches. Find the volume of the drum to the nearest tenth and use 3.14 for pi. So if you'd like to draw a sketch, you can. So if we're drawing a little drum here, a bass drum, of course, they have a picture in your textbook if you want to see, but a bass drum would look something like this. I mean, probably not as long, but it has a diameter of 18. So that's going from one side of the circle all the way to the other side, and a depth is referring to the height. So that's 14 inches, and this is 18 inches. Now, in this case, you don't have to draw yourself a diagram because they're telling you everything. So the diameter is 18, and the height, or the depth, is 14. So if we know the diameter is 18, then we know that our radius is going to be half of that, which will be 9. So we can set up our volume formula now. So the volume is equal to pi r squared h. R equals h equals. R is 9 because it's half of my diameter, and h is 14. So I just plug everything in just like I've been doing. 3.14 for pi, 9 squared, r squared, and then height, which is 14. I grab my calculator and plug this right in. 3.14 times 9, that's a 6, 9 squared, times 14 equals 3,560.76. So let's write that out first. And then I'm rounding to the nearest tenth. So that's going to turn into an 8. 3,560.8 inches cubed. And that will be my final answer. So to finish up, what I'd like you guys to do is I'd like you to try the final your turn I looked at company question, and so pause it, give it a shot. I want you to do that work. You can choose to draw a sketch if you'd like, or you can just do it with the values that are given. All right, so give that a shot and then we'll be done. All right, so here's the solution to the your turn question. I did draw a little sketch just to show, but you don't have to. The company advertises the snare drum is 4 inches high, so that's your height, and 12 inches in diameter. As long as you're reading carefully, you'll notice that that is not what we need. We need the radius. So if you draw your sketch, hopefully you draw the 12 as the diameter, not the radius on accident. To get the radius, I have to take half of that. So my radius is 6 and my height is 4, and after I plug it in, I get 452.16, and rounding that to the nearest tenth, 452.2 inches cubed is the answer. Okay guys, so that's it for today. Pretty simple and straightforward, and enjoy. Tomorrow we're going to get started with cones. Have fun.